Image Processing and Computer Vision Unit (LLL). According to RGPV Exam 2023, complete notes are comment section. Explain region analysis, region properties, external points, spatial moments. Region analysis involves the study and evaluation of the properties of a particular region or area in an image. Regions can be any shape or size and may have different properties that are of interest to the analyst. Region analysis is an important tool for understanding the properties of an image and can be used in a variety of applications, including image processing, computer vision, and pattern recognition. 1. Region properties. 2. These are basic features of a region that describe its size and shape. 2. These properties include: 1. Area. The area of a region is the number of pixels contained within it. 1. It is usually expressed in square pixels. 2. Perimeter. The perimeter of a region is the length of its boundary. 2. It can be used to estimate the shape of the region and the degree of its irregularity. 3. Centroid. The centroid of a region is the center of mass of the region. 3. It can be used to estimate the position of the region in the image. 4. Bounding box. The bounding box is the smallest rectangle that encloses the region. 4. It can be used to estimate the size and shape of the region. 1. External points. These are points that lie outside the region but are used to describe its properties. 1. External points can be used to compute the eccentricity of the region, which is a measure of how elongated or circular it is. 1. Other external points include the major and minor axes of the region, which can be used to estimate its orientation. 2. Spatial moments. These are mathematical calculations that are used to describe the shape and position of a region. 2. The zeroth order spatial moment is equal to the area of the region, while the first order spatial moments are used to calculate the centroid of the region. 2. Higher order spatial moments can be used to estimate the shape and orientation of the region. 3. Mixed spatial gray level moments. These are calculations that take into account both the spatial position and the intensity values of the pixels in the region. 3. They are used to evaluate the texture and contrast of a region. 3. These moments can be used to estimate the texture and contrast of the region, which can be useful in applications such as medical image analysis. In summary, region analysis is an important tool for understanding the properties of an image and can be used in a variety of applications. Region properties, external points, spatial moments, and mixed spatial gray level moments are some of the key properties of regions that can be analyzed to extract useful information from images. Explain boundary analysis. Signature properties, shape numbers. Boundary analysis is a technique used to study and analyze the properties of the boundaries of objects or regions in an image. It involves extracting information from the boundaries of objects in order to classify, identify, or segment them. Two key properties of boundary analysis are signature properties and shape numbers. 1. Signature properties. Signature properties refer to a series of numbers that represent the shape and structure of a boundary. 1. The signature can be calculated using various methods, such as Fourier descriptors or complex moments. 1. Signature properties can include curvature, tangent angles, and boundary length. 1. They can be used to classify and identify objects based on their shape, as well as to track object movement and deformation. 2. Shape numbers. Shape numbers are numerical descriptors that are used to quantify the shape of a boundary. 2. They are often calculated using geometric features such as area, perimeter, and compactness. 2. Some commonly used shape numbers include circularity, aspect ratio, and eccentricity. 2. These shape numbers can be used to distinguish between different types of objects or to compare the shapes of different regions in an image. Here are some additional details on these properties. 1. Curvature. Curvature is a measure of the rate of change of the tangent angle along the boundary. 1. It can be used to distinguish between curved and straight boundaries, as well as to detect corners or inflection points in the boundary. 2. Tangent angles. Tangent angles are the angles between the tangent line and the horizontal axis at each point along the boundary. 2. They can be used to quantify the orientation of the boundary and to identify symmetrical patterns. 3. Boundary length. Boundary length is the length of the boundary of an object. 3. It can be used to estimate the size of an object or to track its movement over time. 4. Circularity. Circularity is a measure of how closely a boundary resembles a perfect circle. 4. It is calculated as the ratio of the object's perimeter to the perimeter of a circle with the same area. 4. A perfectly circular object will have a circularity of 1, while more irregular objects will have lower circularity values. 5. Aspect ratio. Aspect ratio is a measure of the elongation of an object. 5. It is calculated as the ratio of the object's height to its width. 5. Objects that are longer in one direction than in the other will have high aspect ratios, while objects that are roughly square will have aspect ratios close to 1. 6. Eccentricity. Eccentricity is a measure of how elongated or flattened an object is. 6. It is calculated as the ratio of the distance between the foci of an ellipse that fits the object to its major axis length. 6. Objects that are more elongated will have higher eccentricities, while more circular objects will have eccentricities close to 0. In summary, signature properties and shape numbers are important properties of boundary analysis. They can be used to characterize the shape and structure of objects in an image, and to distinguish between different types of objects based on their shape. These properties can be used in a wide range of applications, including pattern recognition, image segmentation, and object tracking. Explain general frameworks for matching. The general frame for matching is a set of techniques used to compare and match objects or patterns in an image with a reference template or database. The general frame consists of 4 main components: the distance relational approach, ordered structural matching, view class matching, and models database organization. 1. Distance relational approach. The distance relational approach involves comparing the distances between feature points in the reference and target images. 1. These distances can be used to compute a similarity score, which indicates how well the target image matches the reference image. 1. The distance relational approach is commonly used for point-based features, such as corners or edges. 2. Ordered structural matching. The ordered structural matching approach involves comparing the structures of the reference and target images. 2. This involves identifying the objects or regions in the image and comparing their relative positions and shapes. 2. The ordered structural matching approach is commonly used for shape-based features, such as contours or silhouettes. 3. View class matching. The view class matching approach involves matching objects or patterns across different viewing angles or orientations. 3. This involves building a database of views or templates for each object or pattern, and then comparing the target image to the appropriate view or template in the database. 3. The view class matching approach is commonly used for 3D object recognition or tracking. 4. Models database organization. The models database organization involves organizing the reference templates or models in a database for efficient searching and retrieval. 4. This involves indexing the templates based on their features, such as shape or texture, and using efficient search algorithms, such as KD trees or hash tables, to quickly retrieve the closest matches. In summary, the general frame for matching provides a set of techniques for comparing and matching objects or patterns in images. These techniques include the distance relational approach, ordered structural matching, view class matching, and models database organization. Each technique has its strengths and weaknesses, and the appropriate technique depends on the specific application and the features of the objects or patterns being matched.